My name is Gianna Bacchetti, and I'm giving a PowerPoint lecture instruction on portable fire extinguishers. We're going to go over some Fire 1 objectives. We're going to define Class A, B, C, D, and K fires. We're going to explain the classification and rating system for the fire extinguishers. Describe the type of agents used in fire extinguishers and the type of operating systems in the fire extinguishers. We're going to describe the basic steps of fire extinguishing operations. The size, the capacity. The purpose of fire extinguishers is to extinguish incipient fires, which traditional methods are not recommended for. Instead of deploying hose line, maybe we'll be able to have an extinguisher brought in and then put out the incipient fire. Many departments carry at least one extinguisher, may carry more. The advantage is portability, but the disadvantage is it's a one-shot device. As a firefighter, we must know which fire requires special agents and what type should be used and how to operate the different types. It's very essential to match the extinguisher and the fire. Some agents are more efficient on certain fires, and some agents will not control certain fires, so it's important to know what fire and what type of agent you're using. Class A fires, they're ordinary combustibles, your wood, paper, some plastic. Water is the most common extinguishing agent. Class B fires involve flammable or combustible liquids, gases, oils, some lacquer paints, and there are different types of extinguishing agents for Class B fires. Class C fires involve energized electrical equipment, and you're wanting to use an agent that will not aid in the conductivity of electricity. Class D fires involve combustible metals, and then some normal agents we might use on other fires. They may react violently. Class K fires, just cooking oils and fats. And then classification of fire extinguishers. And the Underwriters Laboratory developed standards for ratings and classifications. They're rating for its safety and effectiveness. Different classifications, some use letters and numbers. Standard test fires are used to rate the effectiveness of fire extinguishers. Prior slide, the number is used for the amount of fire needed to extinguish, and then the letter is the type of fire. And then, can you read that? Can you maybe turn down the lights? And then just the classification and rating is based on characteristics and the capabilities. And like I said prior, the Underwriters Laboratories, UL, developed standards for ratings and the classification. And like I said, the letters are used to indicate classifier, and the number is used for its effectiveness. Here's kind of an example. An expert using a rated 60B extinguisher can extinguish 150 square feet of a Class B fire. The non-expert using the same extinguisher is expected to extinguish 40% of that. Class A fire extinguishers, the number is related to gallons of water. 1A is equivalent to 1.25 gallons of water. 2A, 2.5 gallons of water. And then the 4A is twice the amount of a 2A rated extinguisher. Class B fire extinguishers, numbers based on the approximate square feet of the burning fuel that can be extinguished. 10B is equivalent to 10 square feet of the fire. 40B, 40 square feet of the fire. Class C extinguishers use agents that do not conduct electricity. And you have to keep in mind, if there's frost on the nozzle and it is discharged, it will conduct electricity. Here's some common labelings on some of the fire extinguishers. This is the traditional lettering system. A, ordinary combustibles. B, flammable liquids. C, electrical equipment. And D, combustible metals. And you do notice that there is not one for K. So they developed a pictograph system. It's just pictures of the different types of classification. So A, you've got your wood. B, gasoline. C, you've got your electrical outlet. And K, kind of grease, oil, your kitchen fires. NFPA Standard 10 lists recommendations for placing and mounting portable fire extinguishers. And then occupancy regulations specify area protected, travel distance, and type of extinguishers provided. 2 factors to determine and obviously to consider is the class of fire that's likely to occur, and then the potential magnitude of that incipient fire. And these extinguishers should be mounted and visibly ready to use. Classifying area hazards. Areas are divided into risk classifications. There are 3 of them, according to the amount and type of combustibles that are present. There's a light or low hazard. That's pretty much just classrooms, hallways, and it's contained limited amounts of Class A and B combustibles. Ordinary or moderate hazards, a little bit bigger, including warehouses that contain Class 1 and Class 2 commodities. Extra or high hazard contain more Class A and B materials. Kind of manufacturing plants. Determine the appropriate placement of fire extinguishers. Some areas may need more extinguishers with more than one rating or more than one type of fire extinguisher. There are different methods of extinguishment. Fires require fuel, heat, and oxygen, and rapid oxidation occurs when a fuel is combined with oxygen. Combustion occurs when fuel is heated to its kindling temperature. Methods of fire extinguishment. We are going to want to cool the fuel, you cut off the supply of oxygen and basically just interrupt the chain of reaction. The types of extinguishing agents. Substance contained in a portable fire extinguisher that puts out a fire. Various chemicals are used, and the best agent depends on several factors. The type of material involved, and like I said earlier, the anticipated size of the fire. Different types. We have water, dry chemical, carbon dioxide, foam, wet chemicals, halogenated agents, and dry powder. Water, it's efficient, it's inexpensive. The only disadvantage is it freezes at 32 degrees. And sometimes it's less effective. Dry chemical, it's a stream of finely ground particles. The different types of compounds are used. Extinguish in 2 ways. It interrupts the chemical chain reaction and it absorbs large quantities of heat. And there's several advantages of water extinguishers. Ordinary, it's suitable for Class B and C. Multi-purpose rating is for A, B, and C fires. Dry chemical additives prevent packing and caking. The disadvantaged chemicals are corrosive. Some primary compounds of the dry chemical is sodium bicarbonate, potassium bicarbonate, urea-based potassium carbonate, potassium chloride, and ammonia phosphate. Carbon dioxide forms a dense cloud displacing air around the fuel. Basically just interrupts the combustion by reducing the oxygen and disrupting liquid fuel's ability to vaporize. Carbon dioxide is stored under pressure as a liquid. It's rated for Class B and C fires only. Does not conduct electricity, it's not corrosive, and does not leave any residue. Carbon dioxide, its limitations include weight, range, weather, confined spaces, and suitability. Foam, water-based foam concentrate solution used on Class A or B fires. And additives depend on compatibility with the fuels. Some foams are approved for polar solvents. They are not suitable for Class C fires, and also cannot be stored or used at freezing temperatures. Wet chemicals, only agents to meet Class K fire rating. Saponification, which converts fatty acids in cooking oils or fats to soap or foam. It creates a thick blanket to smother the fire. It's very effective and easy to clean up. Halogenated agents produced from family of liquefied gases. They're clean agents, twice as effective as carbon dioxide, and there are two categories. You have your halons and your halocarbons. They are stored as liquids and discharged under high pressure. Vapor mist disrupts chain reaction and it dissipates in windy conditions, displaces oxygen in confined spaces. Halon 1211 should rarely be used. Dry powder used on combustible metal fires, Class D. It's stored in a granular powder form. Its commonly used agents are sodium chloride or graphite powder, and you want to avoid splatter. Fire extinguisher design. Use pressure to expel contents. Many extinguishers require pressurized gas to expel the agent. Some agents are self-expelling, and some have a hand-operated pump that expels water or water with additives. Portable fire extinguisher components. As you can see here, there are pretty much 6 basic components of a fire extinguisher. You've got the cylinder, the nozzle, the trigger, the handle. You've got the pressure indicator and the locking mechanism. You have, yes, and just go into more details about the cylinder. Controls the extinguishing agent, the handle used to carry the extinguisher, the nozzle, that's where the agent is expelled from, the trigger, which you squeeze and depress the extinguishing agent, the locking mechanism just prevents unintentional discharge. You've got your pressure indicator, shows whether a stored pressure extinguisher has sufficient pressure to operate. Wheeled fire extinguishers are a little bit larger than most handhelds. Typically contain 150 to 150 pounds of agent, and some of them have long delivery hoses. Portable extinguishers vary according to the extinguishing agent, capacity, effective range, time it takes to completely discharge the agent. And many extinguishers, they differ from their mechanical designs. Water extinguishers, basically used to cool burning fuel below its ignition temperature. They are stored under pressure as well, typically used for incipient Class A fires. Contents can freeze. Water extinguishers, they also load a stream water type. Discharge solution of water containing an alkali metal salt. It's usable to negative 40 degrees Fahrenheit. Most common model is a 2.5 gallon unit. Wetting agent, Class A foam. It's a Class A foam water type. Pump tank water type, range from 1A to 4A. And then we also have a backpack water type water extinguisher. Pretty much used wildland operations. Dry chemical extinguishers contain a variety of agents in granular form. Can also be used on Class C fires, but residue damages electronics. The range of discharge for the dry chemical extinguishers is 5 to 30 feet, depending on the size. And the trigger does allow intermittent discharge. Dry chemical extinguishers, we've got ordinary, they're the wheeled units, the handheld models are wheeled units. The multi-purpose, they have aluminum phosphate agent, and some handheld models, or they're also large wheeled. It just depend on size. But just to keep in mind, you can't use them on Class K fires. Carbon dioxide extinguishers have relatively short discharge ranges, and they're not recommended outdoors or near strong air currents. The trigger mechanism does allow for intermittent operations. Class B foam, aspirating nozzle discharges solution of water, and it foams a foam blanket, covers surface of liquid. It's effective for Class A, B, and not suitable for C or K fires. And it's not effective at freezing temperatures. What chemicals used to protect Class K? Commercial facilities are fixed automatic systems, so portable extinguishers are available, and there are no numerical ratings associated. Halogenated agent extinguishers, they both include halon and halocarbon agents, available in handheld models rated for Class B and C fires, and then the agent is discharged as a streaming liquid. They're non-conductive and leave no residue. Dry powder extinguishing agent is typically used just for Class D fires involving combustible metals. Dry powder fire extinguishers, they do have an adjustable nozzle. Bulk dry powder agents, you can use manually using a scoop or a shovel. The use of fire extinguishers, there's 6 basic steps. You need to locate the fire, select the proper extinguisher, transport the extinguisher to the fire, activate the extinguisher to release the agent, and apply the extinguishing agent, and always ensure personal safety. Locating a fire extinguisher, you got to know the types and locations of fire extinguishers on the apparatus and know where they are around the station. And it is recommended to have at least one extinguisher in your home and another in your personal vehicle. Selecting the proper extinguisher requires understanding of the classification and rating systems. And transporting the best method depends on the size, weight, and design. We use this acronym PASS, PASS, when using or operating a fire extinguisher. We're going to pull the safety pin, aim the nozzle at the base of the flames, squeeze the trigger to discharge the agent, and sweep the nozzle across the base of the flames. And we always want to ensure personal safety, like I said earlier. Approach the fire, always approach the fire with an exit behind you. Have a planned escape route. Never let the fire get between you and the exit. Never turn your back on the fire. Watch for rekindle and wear appropriate PPE and SCBA. Care of fire extinguishers. They must be regularly inspected and properly maintained. Always keep up to date inspections and maintenance. Proper training is required, and we always want to follow the manufacturer's recommendations. Inspection, we want to check extinguishers on the apparatus. It says once a month. Check the tampered seal. And it obviously examine for obvious physical damage, corrosion, or leaks. Also check the pressure gauge, confirm proper identification, check the hose nozzle for damage, and the hydrostatic test date. Maintenance includes internal inspection and repairs, must be performed periodically. Common indicators of need for maintenance. Pressure gauge reads outside normal range. We want to check that. Inspection date is at a tag. The broken tampered seal, things like that. Physical damage, leakage, those all need maintenance. Recharging, it's required after every use. And replace only when properly recharged. Hydrostatic testing measures the extinguisher's ability to withstand internal pressure, and there's a specific test and facility that's required for testing. There's a little tag or sticker on the extinguisher. Must be recent and up to date. And that kind of summarizes here. Yeah. Now we're going to go over like the psychomotor skills of using a carbon dioxide extinguisher. Gonna ask somebody to come up and and we're just going to demonstrate using a lay person and how they are going to use and operate the carbon dioxide extinguisher.
Okay.
So he's going to determine the extinguisher, what he's using it for. He's going to check maintenance, the date, make sure it's in date. Now to use it, he's going to obviously, he's not going to be in full PPE because he's a lay person, but he's going to pull the pin on the handle. He's just going to simulate everything. He's going to remove the horn from the nozzle where it was on the side of the extinguisher. Gives a trigger a quick squeeze to ensure extinguisher operates and discharges properly. Okay, he approaches the fire with his back to an exit. He's going to use the PASS acronym at the base of the fire, squeezing the trigger, sweeping side to side at the base of the flames, stop once the fire is out, and backs away from the fire with his back obviously to the exit. Overhauls fire to ensure extinguishment, and that concludes that skill.